Hello, Professor Kent Lee here. Welcome back to my video series. In this video, I'm going to talk about the word theory, and if I have time, maybe a little bit about laws and hypotheses and models in this video or in a different video. So, the word theory, it's important to understand the way the word theory is used in academic and scientific English. It's not the same as in colloquial English. And a lot of people misunderstand this, and it's really important for understanding your academic field or understanding academic writing and understanding science news and science in general or anything in the world. Okay, let's talk about colloquial examples. In colloquial English, people might say, "My theory is that my English professor is an alien because he's a very strange man." Now, is that a scientific theory? Not really. My theory is that Joseph Biden is not going to run for president again in 2024 because he's too old. That's not a scientific theory. It's not a theory in an academic sense. What that means is more like a guess or a conjecture or a hypothesis, maybe. My hypothesis is that Biden won't run again because of his age. But that's scientifically or academically not a theory. So in colloquial English, people use the word theory to mean like a guess or a conjecture, maybe a hypothesis is what we would call it sometimes if it's more specific. Here's a really important example. People will say, "I don't believe in the theory of evolution. It's just a theory. It's not called the law of evolution. It's just a theory. That means it hasn't been proven true." That is completely wrong. That is a gross misunderstanding of the word theory, because in phrases like the theory of evolution, the word theory is being used in its scientific sense, which is different, and it's important to understand that. Let me give you an example. You know the law of gravity. You learned it in school. When Mr. Newton published his paper on the law of gravity, some people didn't accept this law of gravity. Why? They said, "Okay, Mr. Newton, what causes this gravity stuff of which you speak?" Mr. Newton didn't have an answer. He could prove that it's a thing. He developed a law that explains how it works. He couldn't explain it. He couldn't explain what causes gravity. He had no idea. We had no idea until Einstein came along. And Einstein's general theory of relativity includes a theory of gravity. So there is the fact of gravity, which is more than that. Scientists understand gravity as an attractive force between objects. But the theory of gravity explains, at least on a space-time kind of level, a cosmic level, it has some explanation of what causes gravity, at least on a more cosmic or general, on a big level. It's not a complete theory. It doesn't explain gravity on a micro level, how it's related to other forces, but okay, that doesn't concern us. At least it's a theory that explains gravity on a grand or a large scale. That's the theory of gravity. So you can't just say, "Oh, I don't believe in the theory of gravity. It's just a theory. I'm going to jump off this building and see if I can fly," right? No, it's not going to work. Don't try it. Germ theory of disease. It's a theory that's universally accepted in the modern world. You can't just say, "Oh, I don't believe in that. It's just a theory. It hasn't been proven. I'm just going to expose myself to coronavirus and I'll be fine." No, it doesn't work that way. It's a theory that explains how diseases are transmitted, diseases that are caused by bacteria and viruses. A theory is not the same as a law. And in science or other fields, it is not the case that a law is equivalent to a theory. In other words, it's not the case that a theory gets proven and becomes a law. They are completely different creatures altogether. They're like apples and oranges. They're different things, essentially. A law is a simple statement. It can be an equation or a formula or a simple statement. Okay, some of Newton's laws of motion. For every action, there's an equal and opposite reaction. Okay, it's a simple statement. And a law is generally true. Now, Mr. Newton didn't know about black holes or traveling near the speed of light, but for the normal universe, his laws of motion and the law of gravity work. A law is a simple statement, a single sentence, or a formula or an equation that is generally true, at least for intended domain. A theory is something bigger. It is more complex. There is the fact of gravity, there's the law of gravity, then there is a theory of gravity, which provides an explanation, some explanation for kind of how it works and what causes it. There's the fact of evolution, and there's the theory of evolution. It's designed to explain something. So that's the key here. A theory is a more complex framework. It's a framework, and it's designed to explain something. It's an explanatory framework. You could say it's an explanatory conceptual framework. So, for example, Einstein's famous equation E equals mc squared. That's a law, and it works. Been proven time and time again. That is a law, and it's part of a set of other statements and equations that form Einstein's special theory of relativity. There are two theories. There's the special theory of relativity that talks about how mass and light and energy are related to each other. So it explains something. The theory of evolution. The theory of evolution is designed to explain the variety and diversity of life forms on Earth. That's what Charles Darwin was trying to explain when he formulated the theory of evolution. In his studies and his travels, he noticed the variety and the diversity of life forms, similarities, and differences. The theory of evolution is designed to explain that. The variety and diversity of life forms on Earth, their similarities and their differences. So the theory consists of several different statements about, for example, complexity arising from simpler life forms. There is a part about natural selection. By the way, survival of the fittest is not a part of the theory. That's a misunderstanding. That somebody else made that up, and it's not part of the theory of evolution. There's a part about mutation. Now, mutation in biology simply means change. Changes arise, and mutations and changes arise due to genetics and other factors. And there are one or two other statements about the mechanisms that drive evolution and such. And since Darwin's time, we've kind of modified and added to that. We have a better understanding of what causes evolution, the mechanisms, the forces involved and such. So there's a set of different statements about different aspects of evolution, and together they form a coherent conceptual framework. So theory is a coherent conceptual framework that explains something. In other words, it's an explanatory framework. A set of ideas that fit together coherently and explain something. Why do we have the different diversity of life forms with their similarities and differences? The theory of evolution is not intended to explain how life first began. That's a different theory, which biologists are working on. That's a different thing. The theory of evolution does not address the question of what caused life to first arise, but explains what happens when you do have life. So, the theory is an explanation of the variety of life forms that we have. The special theory of relativity explains how matter and energy are related to each other. Then Einstein later came out with the general theory of relativity. It's a bigger theory that also explains space and time and how they're related and stuff, and it includes a theory of gravity. So that's what a theory is. It's important to understand the word theory in an academic sense. So a theory is a conceptual framework. And many academic fields use some kind of a theory, whether you're in literature or history or other humanities fields, in a social science field like linguistics or psychology, or of course in science. So a theory can be something that's been proven. There are theories that have not yet been proven. There are some theories that have been disproven, and there are theories that have been proven and they are accepted as fact. Now, you might hear that, well, one definition of a theory is that hypothetically, it could be disproven someday and overturned. Okay, maybe true. With some, like with the theory of evolution or Einstein's theories, hypothetically, yeah, if we could prove that the universe is not real, that the universe is part of some computer simulation by some super alien race, okay, that would overturn the theories of evolution or relativity. That's extremely unlikely. Probably not going to happen. Okay, we're probably real. We're probably not part of an, a simulated universe in some alien supercomputer somewhere. There's so much evidence for the theory of evolution. It's been accepted as fact, as true. There's so much evidence for Einstein's general and special theories of relativity. Does it affect your daily life? Well, do you use navigation apps or devices in your phone or your car? Those depend on Einstein's general theory of relativity, because your phone app or your navigation system in your car has to communicate with at least 2 satellites in space, and those satellites are experiencing time at a different rate than you are here on the ground, because they are in low gravity and they are moving very fast to stay up above where you are. They have 2 different effects on their time. They experience time differently, and Einstein's equations tell us how to correct for that. So they give you correct information on how to get to the store. So those are important. If you're in an academic field, you are going to probably deal with some kind of theory or theories. Your field might have one main theory. There might be people who do different theories, different perspectives, especially in social science fields. Let's look at some other examples. Big Bang Theory. It's designed to explain the early development and origins of the universe. Now, it doesn't explain what caused the Big Bang. For that, there are other theories that scientists are looking into. But once you have this little thing that where the universe began and how it started to expand and led to the development of the universe, that's the Big Bang Theory. It doesn't explain where this thing came from and what happened before that, how long this thing was here before it started to expand. Okay, that's a matter of different other theories. But there's a lot of evidence for the Big Bang Theory. Chaos theory, you might have heard of that. It's a theory about complexity, mathematical complexity. It's beyond my head. It's beyond my understanding. But you can read some interesting books that will explain it to you in non-technical ways that are quite interesting and cool. Germ theory, how microorganisms cause disease. It's been proven. It's a thing. So, especially the scientific theories, chaos theory is more of a mathematical theory. There's plenty of evidence for it. But when we talk about a theory in science, it's an explanatory framework. And another thing in science is we care about proving it true. A new theory comes out and scientists try to prove it or disprove it. They do experiments and they try to prove it or disprove it, knock it out of the air. So science is concerned with proving theories true. Now, in humanities, it's different. So we talk about literary theory, for example. Literary theory is a set of principles for understanding literature, different types, different genres of literature. It's a set of principles for interpreting literature and understanding authors and readers and how they connect with each other, how literature affects readers, and how readers interact with the literature, literary devices, and things like that, use of language in different genres and types of literature. That's literary theory. It's a general set of principles. It's not something you can go out and try to prove or disprove scientifically. So in humanities, a theory is something that gets accepted because a group of scholars, the community, the academic community comes to accept it as useful. So general literary theory has been around for a long time and it works. It's a set of principles that work for analyzing poetry and short stories and novels and stuff like that. Now, then in literature, there are more specific theories for dealing with specific issues. There are theories in literature for cross-cultural issues, cultural issues in literature, like you have, say, novels by Asian American novelists or Asian American characters or Latin American novels. So there are, I think, one or two major literary theories that deal with cultural issues in literature and how that affects interpretation and understanding of characters and stuff. And there are groups of scholars who will accept this theory because they find it useful. It works. It helps us to find new insights and talk about these kinds of issues in the literature when we analyze and interpret the literature, and we look at the characters and the authors and how it affects the readers and what authors do with these kinds of features in the novels. It's a theory gets accepted in humanities more often based on practical reasons, pragmatic reasons. It works. It gives us new insights. It helps us to do our research, helps us to understand things better. Likewise, there are theories in literature about gender issues and gender identity in literature, characters and authors and plots and such. There are other specialized literary theories for more specialized questions, and a group of scholars within literature community will accept this theory because it works for them. In science, it's kind of different because you have to prove a theory before you accept it. You have to do, and we'll talk later about how that works. But a theory has to be proven in science and humanities. It's maybe more accepted for practical or pragmatic reasons. It works. A couple of other examples. Social sciences, again, more often in social sciences, we'll try to find some evidence. Maybe we're not trying to prove it through experiments, but enough evidence will accumulate that a lot of people will come to accept a theory. For example, in economics, there's game theory. If you see the movie A Beautiful Mind, that's a good movie to watch. It's about the famous mathematician Thomas Nash, who developed game theory. It does a good job of understanding Nash as a person. Unfortunately, it doesn't really show you why he's famous or help you understand why he was so famous and so important because of his game theory. It's a theory for consumer behavior and consumer choices in economics, and it's a really important theory, and it explains a lot of things, so a lot of economists accept it and use it for their research. Attachment theory in psychology, there's good deal of psychological evidence, scientific evidence for this, and it's basically a theory about babies forming emotional bonds or attachments with their parents or caregivers within the first 3 years of life. And if they form a healthy emotional bond with a parent or parents, they will grow up healthy and have healthy relationships generally. And if they don't, they will grow up to have difficulties in their adult relationships, especially intimate or close relationships. And there are different kinds of problems that they can have according to the theory, and that's been pretty well accepted because there's a lot of scientific evidence for this. It doesn't mean that if you had a poor attachment with your parents, you are messed up for life. You can overcome it. You can educate yourself. You can maybe even get therapy and overcome these problems. Linguistic theories. Let's talk about that. Chomsky, for example, is famous for his theory of universal grammar, and it is a theory about child language learning, children learning their first language. It includes the critical period hypothesis that they have a certain window of time in which to learn their first language through natural input, and if they don't get it, they won't really learn the language very well. There's a lot of scientific evidence for this, and it's generally accepted by a lot of linguists and biologists. Universal grammar also says something about the sort of abilities that they're born with, the sort of language stuff in their brains, and it has some things that's kind of shared by all humans. The theory has some things to say about that kind of stuff. What kind of knowledge children have to, general knowledge about language, human language children have to be born with, and such. There are a few people who criticize it, some valid criticisms, some not so valid, but it's a generally accepted theory, and it should not be confused with this theory of generative grammar, which is a different theory. It overlaps somewhat with UG, universal grammar, but generative grammar is more of a theory about the syntax or the theory of grammar in all human languages, universal features of grammar in all human languages, including a lot of really abstract stuff. And it's really, really complicated. There are other theories in linguistics. about a language and about grammar and such, different linguists will maybe follow a different theory or work within a different theory. There are competing theories with generative grammar or universal grammar. That's not important here. But in linguistics, there are a variety of different theories that you can choose to work in depending on what you're interested in. Some theories focus more on language as a cognitive, psychological phenomena that can be understood psychologically, because language is viewed as being related to other aspects of human cognition or psychology. Then there are, especially within the Chomskyan tradition, more of a focus on language as a logical mental system that is unique and different from other psychological aspects of psychology and human knowledge and cognition and such. Then there are people who focus more on language as a social phenomenon and use more social theories, sociolinguistic theories about language and communication and interaction. And their objectives are very different, and there are different theories there that are all interesting and worthwhile. So a theory is an explanation. For example, you can try to explain language maybe socially as a social system. You can try to understand language theoretically as its own unique thing that's really unique and something that's inborn and kind of abstract and shared among all humans and all human languages. You can view it as something that's kind of more cognitive and psychological, that's related to other mental systems and psychological abilities and such. And they're all valid. They all are important ways of understanding and studying language. So theories are important. Theories are different than what you might understand in normal English. A theory in academic and scientific English is an explanatory framework. And in science, it has to be proven before it is accepted. In other fields, especially in humanities and some social science fields, it might get accepted because it works, it has practical value and such. But still, a theory is an explanatory framework. It's a framework for explaining something. It is not the same as a law. A law is a simple statement or general statement. A theory is something that is more comprehensive. It's an explanation. A law may not explain why things are. A theory is an attempt to explain why things are. And it tries to explain a particular question. Like, why do we have this diversity of life forms on Earth? How are time and space related? How are matter and energy related? Okay. How does human language work? Things like that. Theories attempt to explain something. And that's the key difference between a theory in academic English versus the word theory in colloquial or commonplace English. In the next video, I'll say a little bit more about related concepts. I'll talk a little bit more again about laws and hypotheses and models and how science works. All right. Hope your brain is kind of full now, and I'll fill your brain up more in the next video. So until then, I'll see you later. Goodbye.